Hello and good afternoon, CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP Switch course, and this afternoon's video tutorial is going to be on the Cisco Networking Academy in-class lab that we do on the actual Cisco hardware, Lab 7-1, where we're going to be taking a look at NTP. And the network time protocol, we're going to build off of Discovery Activity 12 and take a look at how things function on real hardware. As you can see here, this is our setup, and this sort of full mesh setup that we've had throughout the course is going to stay intact here as we do Lab 7-1. So let's go ahead and dive in. The premise of this lab is that DLSW01 is going to be the NTP master, and DLSW02 and the access layer switches ALSW01 and 02, those are all going to be clients. So I've actually done all of the baseline configuring that would need to be done up to this point. So I'm starting, if you're following along in the Word document, I'm starting on step 4. And it talks about setting the system clock. So let's jump over here to DLSW01 and go from user exec to privilege exec. And if I were to say show clock, this is going to give us the current system date and time, and I am so glad that DLSW01 is going to cooperate with me here. So take a look at what time the system believes it is. And again, that's Coordinated Universal Time. UTC is Universal Time Coordinated, or Coordinated Universal Time. So we can manually set the clock, and again, having accurate time on systems is critically important. I've already mentioned what I believe to be one of the most important reasons, and that is logging. Because if you have to go back and take a look at any forensic information on a switch or a router, there is nothing more disappointing than finding out that your time sources, or that the times on those components, are out of sync. So it is very, very critical. I really like how the lab mentions, if you're doing any kind of X509 certificates or PKI, that you need to make sure that you've got your time synced up as well. And again, goes back to taking a look at event correlation, right, or attack identification. But again, two very, very important things that you need to take a look at. So as you can see here, if this was a 1, and this switch has been up for a number of days, I wiped out the config, but typically you'll see Monday, March 1st, 1993, and that's the time the system clock starts. I believe there's some kind of a story behind that as to why it's that date, but I cannot remember why it gets set to that by default. All right, so we've done the show clock command. It's clear that it is not 1993. So what we want to do is we want to set the clock. So now this is something that you do from privilege exec, right? We don't need to go into global config to set the clock. We can do it right here from privilege exec. So just like we did in the previous activity in Discovery Activity 12 on IOU in the Cisco Learning Labs, let's go ahead and get the right time in here. So I'm just going to take a look up here, and we've got 15:43:29. So I'm going to go ahead and set it to Eastern time. So 15:43. And actually, let's do this. If I'm -5 from UTC, let's go ahead and we'll set it for UTC time, actually. So we've got -5, so 20. And I'll set it to 44:00. So we'll catch up here. Now, you'll notice that the day of the month, well, today is the 4th. The month is April. And what year is it? Well, it is 2016. So there we go. We just set that right as that clock up here, our system clock, rolled over to 15:44. So you can see that we get this nice syslog information here where we get the facility, the severity level, and then the mnemonic, right? Again, the facility is always preceded by the %. The severity level is the numeric representation between the two dashes, and then the mnemonic kind of giving me a hint as to, well, what system facility has been impacted here, and then we get a nice description. System clock has been updated, right, and then configured from console. So now when I say show clock, you can see that we are accurately set here for UTC time. Now, again, remember when we looked at the IOU, right, in the Cisco Learning Labs, what was the default time zone there? Exactly. The default time zone there was Pacific Standard Time, or PST time. And again, that is an IOU-centric thing. So on real Cisco hardware, what you're going to have is you're going to have UTC time set up on your system by default. So let's go ahead. They're asking us here to change UTC time. I always use UTC time, especially given the fact that we have systems in Alaska, Colorado, all over the place, right? Florida, Virginia, Maryland. So when you've got things that may be across different time zones, UTC is typically a good choice. Now they're asking us to set this to Central Standard Time. So step D here, or I should say substep D under step 4. We're going to go ahead and just follow along here. So we're going to go into global config. And in fact, let's do this. I'm in the Eastern time zone, right? And let's go ahead and put the name. We'll say East, and I'm going to put underscore MD for Maryland. So, and again, that can be, that East underscore MD can be anything we want. That's just a name that we're using to identify the time. And in IOU, it was 7 characters. Let's see if it does the same thing. And did it tell me? Let me see how many characters. Does it give us a list? No. So let me say Eastern underscore Maryland. So Eastern time underscore Maryland. And then what's the offset from UTC? Well, -5. So let's hit enter. And interestingly enough, it took that on IOU. If you watch my previous video, Discovery 12, it limited us to 7 characters for the time zone name. So right there, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we didn't have any problem. So we just set the time zone to Eastern Standard Time. Now, the next thing that we want to look at, and this is actually by default, the switches will do the daylight savings rule, and it's referred to as summertime, right? So when you say clock summertime, so if I were to say clock summertime, you can see here that name of the time zone in the summer. So we're going to use that same one we had before. So Eastern time zone for Maryland. And is it going to be recurring, or do we want to set a hard date? So we're going to say recurring because the code is going to know what the daylight savings times when we fall backwards, typically November 9th. Well, I should say not typically November 9th, but right around November 6th to the 9th, that first weekend in November. And then the first weekend in March is typically when we roll back. No, the fall back and then spring forward. So March, we push the clocks forward an hour and it gets dark really early. I'm sorry, stays lighter later. And in the fall, we fall back an hour, and then therefore do show clock. It gets darker earlier. So we're going to say do show clock detail. And so here's what we have right now. And actually, it looks like it did not err. It just simply didn't take. So are we limited to 1, 2, 3, 4, 5, 6? So we are limited to 7 characters. But it doesn't give us an error. It just simply drops any characters over 7. So interesting. All right. So here is the Eastern time, 4:48. And so I'm actually a little off. So what would I have to do? I would have to go back and say that the Eastern time is 4 hours off. And then, I'm sorry, 6 hours off. I'm going the wrong way. So we're 6 hours behind UTC. So now that should match up. There we go. And that actually matches up with the Eastern time zone. And it's kind of funny here where it didn't trim it there, but it did trim it here. So interesting. Okay, so time source is user configuration. And what does that mean? Well, that means that we just manually configured it. Now, as the lab points out, this is very true. Manually configuring your time, because after a while, the time will skew or drift from the actual time that you set it to. And then you end up with inaccurate time, which is why you want to configure NTP. And so here's exactly what we're going to do right now on DLSW01 is we're going to go ahead and say NTP master, and let me NTP master unrecognized command. So give me 1 second here. Do show version. So 12255 SE10, that should not be a problem. And it looks like this code is not going to let me run as a master NTP server. So that is interesting. So here's what we'll do. Let me do this, because one of these routers up here, which is running 15.5 code, let's say global config NTP master. Yeah. So here's what we're going to do. That's interesting that the 12255 does not support that. So I'm going to pause here real quickly. Again, I'm using 3750, so kind of old, but still, expectation is that you would be able to set them up as an NTP master. I'm just going to drop a router into the setup, and that's going to be our NTP master, and then everybody else will sync up to the router. So let me pause real quick. Let me plug a router in, and then we'll continue on our way. All right, so here's what we're going to do. I just plugged the router into interface FA101. So let's say switch port host, switch port access VLAN 99. That's the VLAN we have set up, and then no shut. And then router 1 here, we're going to go into interface FA 0, was it 00 or 01? I can't remember now. So let's do show IP interface brief. It should be the one that is up, so administratively down. So let's go into, let's say no shut, and do show IP interface brief. I think it's FA01. Show IP interface brief. And that is up, down. Let's go into interface FA00 and say no shut. And we should, there we go. So it's 00. Okay, so let's just give it an IP address here. So we'll say IP address 172.16 dot and show IP interface brief 99.111, and we'll make it /24 as the rest, and we'll say we already said no shut, so let's say do ping 172.16.99.1. So can I ping DLSW01, to which I'm directly connected? I can. What about 2? Do we have reachability to DLSW02? We do. What about DLSW03? I'm sorry, ALSW01, which is .3. We do, and then 4, which is ALSW02. All right, so we're ready to go here. So let's exit out, and we're going to go ahead and real quickly step through what we just did for DLSW01, which was we took a look at the show clock, or let's say do show clock. And you can see that the time here is actually a little more accurate. It's got the right day, month, and year, but the time is definitely off. So we'll set the clock. So let's say, and actually let's get out of privilege exec. Well, yeah, no, that's right. We got to go back into global config. Sorry. Go back into global config. So we're going to say clock, time zone, and I'm just going to say Eastern. And we are -6 from UTC, and so do show clock. So there we go, and 118. So what are we off here? So I actually need to set the clock correctly first. So let's get out of here and let's say clock set, and this is going to be 15:56:00, and it is the 3rd of April of 2016. and we're pretty close. We're within 30 seconds. So we'll hit enter there. Now when we say show clock, you can see that we're pretty close, right? We're about 30 seconds away. So show clock detail. Source is user configuration, so we're good to go there. And now we'll go ahead and set up the, we'll set up the clock summertime as well for Eastern and recurring so that it continually happens. So end, write mem, and show clock detail. Give it a second here. All right, so there we go. So the time is 16:56, and actually put the summertime in there and I kind of tweaked it. So 16:56, and let's make that, let's sort that out. So we want to bring back that and do show clock. Did that change on the other one, I wonder? Yeah, so we are -5 then. So do show clock detail. And I'm going the wrong way here. I'm having problems keeping my time straight. All right, so 17:57. So we're 2 hours off right now. So are we, there's no way we're -7 from UTC time. We are apparently -7 from UTC time. Interestingly enough, when I set that here, do show clock detail, did that do the same thing? It did, actually. So I'm wondering, no, that's going the opposite direction. Huh. All right, so we're going to stick with what we've got here, which matches up do show clock detail with my current system time. So we're going to say Eastern. We've got our time sources user configuration, and so this is going to be our NTP server, or I should say our NTP master. So let's go ahead and do that. So NTP master, there's a question mark up there. So we're going to make this a stratum. What are they asking for here? And again, remember the stratum is the reliability of the server. So we're going to say NTP master 9. And again, it goes from 1 to 15, 1 being the most reliable, 15 being the least reliable. All right, so we've got it set up as the NTP master. Let's go ahead and actually let me put in a host name here for router 1. So we'll say write mem. Now we're going to come over and we're going to walk through on all of the 4 switches. And where is, there we go. And why is that not showing? Hold on one second here. There we go. All right, so on all of the switches, we're going to go into global config, and we're going to say NTP server, and then we're going to give the IP address 172.16.1.111, because that is the server that we're going to be using. That's the router, router 1. So do show NTP status, and you can see it shows we're unsynchronized, stratum 16, no reference clock. Do show NTP associations. You can see that we've got what's configured, right? So this is what's configured. We're saying, hey, you're going to use 172.16.1.111. That is router 1, right? So let's see if we've got debug NTP and all. So let's debug NTP all on router 1 here and see what we get back, if anything. And let me take one last show IP interface brief. Let me double check to make sure that it is. And the IP address, hold on, 99.111. And these guys are do show IP interface brief. Yeah, okay, 99.3, 99.1, 2, 3, and 4. All right, so we're good there. So we're going to leave the debugs on over here. And let's see, do show clock. So this thinks it's March 4th, 1993. So there is a huge drift here, right? I mean, this is so far off that it may not sync up because the drift is so extreme. So let's go ahead and set our time zone anyway. So we'll say clock time zone. We may have to get this a little bit closer, and then we'll say Eastern here and -7. And then clock, summertime, Eastern, recurring, right, for daylight savings time. Now when I say do show clock detail, you can see that we're set here. So when does summertime start? And this is showing March 14th, 93. This is showing Sunday, November 7th, 93, because this is so far off right now from the actual time that it's questionable as to whether or not this is ever going to sync up. Now, when it does, it should show stratum, what do we use, 9? So it should show stratum 10 because we used a stratum 9 command when we set things up. So let's walk through and let's do those same commands here on ALSWO2. So show clock. Again, this thinks it's March 4th, 93 as well. So NTP server 172.16.99.111. And let me make sure, do show NTP server, or no, do show run include NTP. And there we go. I thought that I'd put that in wrong. So we're going to say no NTP server. And let's get this right. NTP server 172.16.99.111. All right, there we go. So now let's give it an opportunity here. So we'll say show clock, show NTP status. So you can see it's not taking, and there we go. That actually synchronized pretty quick. So clock is synchronized stratum 12, show clock. And look at that. We now have accurate time, date and year. So show NTP associations, and that's what it's going to show for the NTP associations, right? So the reference clock, and this was referenced in the reading, is that when a router or a switch is set up as the NTP master, the reference clock, it's going to reference an internal, and this is a not a loopback, a local address, right? This is that reserved range of 127.000. So that is within that range, and this is an internal IP used by the router that will show up as the reference clock. And so that will tell you, when you see that 127.127, and it's .x.1, and so this third octet here will change, or it could change. But when you see 127.127, that's telling you that this NTP source is using its own clock, that it is the time source. And you can see it's set for stratum 9, which is why we show up as stratum 10. All right, so that takes care of ALSWO1. Let's knock out ALSWO2. So we've got that set. So clock, summertime, Eastern, recurring. And let's go ahead and say do show NTP associations and take a look. We are already associated. Do show NTP status. And in this environment, it's really quick. I've seen this take upwards of 15 minutes. So take a look over here. And we see we've got some messages scrolling in, right? These are our NTP messages. So received from 99.4, that's ALSWO2, right? NTP messages are coming in. Next action is 3. And then we're receiving information, right? NTP messages being exchanged back and forth. So we'll leave that debug going. So we're good to go here on ALSWO do show clock detail. So what is our time source now? Well, the time source now is NTP. So that shows that we've successfully synchronized with the NTP server. All right, let's go back over here to DLSWO1 and let's say NTP server. And then clock and summertime, Eastern, and recurring. All right, so how about a show NTP status? Right, so we're still unsynchronized right now, And then take a look at that. It just took one command before it went from unsynchronized to synchronized. Show NTP associations. And there we are right there. That's the master. We are synced to the master because of that asterisk. And that is the configured IP address because of the tilde. Again, reference clock of 127.127.11 clearly indicates that clock that we're referencing, or I should say the NTP master that we're referencing, is using an internal clock, right? That it is not referring to another NTP source from which it is then providing us the NTP information. Then finally, we'll wrap things up here with DLSWO2. We'll go from user exec to privilege exec into global config, NTP server 172.16.99.111. And then what we're going to do here, clock summertime Eastern recurring. There we go. So let's say show NTP status. So we're unsynchronized. We're synchronized. I mean, take a look at how quickly that worked. Now, and again, in real life, it may or may not be this quick. Again, I've had to wait upwards of 15 minutes sometimes for things to synchronize. So show NTP associations, and there we go. All right, so we've got all four routers set up. So now we're in part 2 of the lab, where we're going to secure NTP operations. We're going to be using access lists and authentication. So what we're going to do now is on our NTP master, first thing we're going to do is say you all. Well, let's kick off debugging, or turn off debugging for right now. And so we're going to configure authentication here. So we're going to say NTP, let's get into global config, NTP authenticate, and then we're going to say NTP authentication key. So what is the key going to be? Remember, we're just simply authenticating. We're not authenticating the clients. We're just authenticating the source here, right? So NTP authentication key 1 MD5. And again, if you take a look, you can only do MD5. And what are we going to have the key? We'll make it ABC123, right? And then NTP trusted key 1. So if I was to say, and actually they want us to use, let me make sure we're going to do this correctly here. Enable the NTP, and then we want to do this between, so it says configure it on DLS1 and DLS2. And so let me make sure. So we wouldn't do this on DLS2. We would only need to do this on, and hold on a second, I'm trying to see why they don't have us do this on ALSWO1 and O2. Oh, repeat these commands. Sorry. Okay, repeat these commands and verify that the clocks are synchronized. All right, so we are doing it on all four. It gave the impression on substep A here for part 2, step 1, that you only did this on DLS1 and DLS2, but it looks like they're going to want us to put this on, and I was wondering why they would leave out those two. So let's drop down here. We'll come to ALSWO1. Say show NTP association, so we're still associated, and then we'll say show NTP status, and we're synchronized. So let's put in, let's put in that authentication information. So NTP authenticate, NTP authentication key 1, MD5 ABC123, and NTP trusted key 1. So we'll say do show NTP status, and then do show NTP associations. And you can see that we are still associated with the master server, which is router 1. And then let's go ahead and we're going to drop these same commands in. NTP authenticate, NTP authentication key 1 MD5, and then ABC123, and then NTP trusted key 1. And then we'll drop that in here on DLSWO1, go into global config, NTP authenticate, NTP authentication key 1 MD5, ABC123, and then NTP trusted key 1. And again, we're not authenticating clients, right? We're simply authenticating the source. And actually a good point. I just saw this here. So, and the reason I keep stressing that we're authenticating the source is that devices are still going to respond to unauthenticated requests. And this is the reason you want to enhance this authentication scheme here with access lists. Because what you wouldn't want to do is set this up and then think, oh, well, only these clients that have authentication set up are going to be able to work with NTP, and that's not the case. Again, it doesn't authenticate clients, it simply authenticates the source. And so other devices, if I were to plug in other switches, as you can see right now, right? So DLSWO2, we haven't done anything on this. So show NTP status, it is still synchronized. It is still getting its information. Show NTP associations, it's still associated and synced with the master. So even though we've set up the NTP authenticate, the authentication key, and the trusted key, it's all kind of irrelevant from a serious security perspective, because it doesn't matter whether I have it on the clients or not, because it's not authenticating the clients. Like you see right here, DLSWO2 is a client. It's simply authenticating the source. And when I'm talking about the source, we're talking about router 1. That is all it's authenticating. Okay, so let's go ahead and finish up here. Trusted key 1. All right, so we're good there. And let's say write mem. Let's come up here to DLSWO2 and let's do the same thing. We'll get into global config. So NTP authenticate, NTP authentication key, authentication key 1, MD5, ABC123, NTP trusted key 1. All right, so now we have the proper information on here to authenticate the source, right? So that's what's being done, is we're authenticating the source, not the clients. And we are still synchronized. So that's kind of, quote unquote, part 1 of how we can enhance the setup. But again, remember, that is not securing the setup. So now we're on to step 2, where we're going to control NTP access using access lists. So, and it's actually nice here, step 2 mentions, it says configure an access list so that polling can only come from members of the 172.16.00/16 network. NTP masters must allow peer access to source with IP address 127.127.x.1. Now remember, that is an internal IP address that when we run that NTP master command, that is being created. And so the local router synchronizes to that IP, the 127.127.x. In our case, it's 127.127.1.1. So we have to allow access to that, or else it's not going to be able to keep itself with the internal values, to keep itself synced up. So let's go ahead and jump on to router 1 here. And it's on router 1. Remember, router 1 is the NTP master in our setup. We had to do a minor modification there. So I'm going to go ahead and say access list 1 permit. And the first thing we're going to permit is at 127.127.1.1. Now, when I do that, what if I was to say, and I'm not going to, so there should be a second statement here. Remember, we need to allow everybody on the 172.16.0.0/16. But I'm not going to do that right now. Let's see what happens here. Show NTP status, right? I'm synchronized. Show NTP associations. Whoops. Associations. And I'm all synced up and I can see the master and everything is great. What happens when I say NTP access group? If I do a question mark here, you can see we are going to do a peer, right? And which access group, or I should say, which access list number did we use for the peer, right? Remember those choices. You have peer, serve only. So for the peer, which is to that 127, I say peer 1. If I were to come up and say, and here's the 4 choices you've got, right? Or I should say peer, query only, serve only. If I were to say serve only 1, right? Let's take a look and see what happens here. Because that access list 1 is not allowing anybody from the 172.16.0.0/16 network to come in. So for serve only, it's being blocked. You can see where we're still synced up here, right? It still shows a synchronization. Let's see if the polling interval, if after a period of time here, the polling interval is going to come up and say that we are unsynchronized. And so our polling interval should be, looks like 64 seconds. So we'll give it a couple seconds here. Let me actually create, while we're waiting for that, I'm going to create the correct access list. So I'm going to say access list 2 permit 172.16.0.0.255.255. And again, these are just simple ACLs that we're using here, standard ACLs, I should say, not extended ACLs, because we can do it based off of the source. All right, so let's check back here and let's see, did it drop? Because obviously, still shows synchronized, still shows associated, and it may be just a matter of show NTP status. Clock is synchronized, show NTP associations. Yeah, it's just probably a matter of timing and being patient enough to allow it to time out. Because if we were to say, oops, sorry, do show NTP status on the master here, router 1. Okay, so system poll interval, last update was 15 seconds ago. And here's our reference, right, that internal clock. NTP uptime, reference clock, clock offset, root dispersion. So yeah, we should see, if that is set up correctly, do show run, include NTP. And we have peer 1, and that's good, serve only 1. And that should work, because that's referring to ACL 1, which does not allow anything from the 172.16. So yeah, it still shows it's synced up. All right, so here's what we'll do. We'll go ahead and move on. I've got the right ACL there. So let's say no NTP access group 1 serve only. And access group, and again, I could provide server and query access, provide only server access. So we're providing serve only access here, and we'll use ACL 2. So that's actually the correct ACL that we would want to go ahead and use. All right, so let's take a look at the other devices that are out there. They're still going to show, they should still show that they're associated. And they do. And show NTP status, they're synchronized. And they are. And let's see, I believe that that is all they have us taking a look at here. Yeah, and so that's actually everything. Let's try, well, actually, let's, since it's already the 172.16.99, and we've got that in the VLAN. Yeah, that's going to be a little difficult to do. I was going to say, what I was thinking about doing was changing the statement here on router 1 to list only specific IPs instead of that whole subnet. So let's do this. I am going to say no. So let's take this off here because I want to see this ACL work and actually deny synchronization from one of the clients. So no NTP access group serve only 2. I'm going to say do show access list. and let's say no access list 2. All right, so let's say access list 2, and we're going to permit 172.16.99.1.2 and .3. And so that's going to be DLS1, DLS2, ALS1, but not ALS2. And then let's come back with NTP, NTP access group serve only 2. Now, I've left out the access layer switch 2, which is ALSWO2. So, if we come here and we say show NTP status, so he shows he's synchronized, show NTP associations, he shows that he is associated. Well, let's do this. Let's remove no NTP server 172.16.99.111. Do show NTP status. So he shows he's unsynchronized. Do show NTP associations. He's associated with nobody. Now over here, let's go ahead and say debug NTP, and we're going to debug all. So we're going to debug all. So we'll come back over to ALSWO2, and we're going to say NTP server 172.16.99.111. Let's jump over here, and let's see on router 1, do we see anything that would indicate that it's going to be denied? So reserve, and there it is, dropping messages. Let's quickly kill this, right? This is fantastic. I love the debug messages. You all. All right, all debugging is off, and this is what I wanted to see, right? I think it's great that we walk through it in the lab and that you set it up, but how do you know that it's actually doing what it says it's supposed to be doing? So let's take a look at this. Message received from 172.16.99.4. That is ALSWO2. That was the one that we just left off of the ACL that allowed access in. NTP receive, message received. And what does the response? Dropping message. RES don't serve. Restriction, do not serve restriction. Message received from 194 on interface fast Ethernet 00. Message received, dropping message. So it's receiving the messages, but because of the NTP access group statement that we have, that we set up with the ACL, we did not allow 172.16.99.4. So this proves that when messages show up from 172.16.99.4 requesting NTP services, that it is not in that NTP access group statement, therefore it is going to restrict do not serve. So it is not going to provide NTP services as the NTP master over to ALSW2. And again, very important to take a look at this from a debug perspective, because again, it probably would have timed out at some point, but it certainly gave the impression that the ACL wasn't doing what we had anticipated it should be doing. But again, we pulled the NTP off ALSWO2. We set up the access list so that it blocked it allowed everybody except ALSWO2, and then we kicked NTP services back on, and there is the beauty of the debugs, right? Validating the fact that we are not going to get ALSWO2 to pull his time services from the server. So do show NTP association. Let's see what we see here. So the association, take a look, right? It's configured, no reference clock, stratum 16, and it's not synchronized. Do show NTP status. Unsynchronized. And so he is going to be denied. But let's do this. Let's come back over here. Not on router 2, but on router 1. And did I accidentally drag ALSWO2? I actually was on the wrong... Or no, that's right. I actually drug it to the right there by accident. So here we go. So let's come back over here and let's add into, let's say, global config, access list, to permit 172.16.99.4. Now let's say debug NTP all. And let's see what happens if we get something that comes in from 99.4, right? Because he should still be sending those NTP requests. Will he sync up? So ALSW02, NTP status, right? He's still unsynchronized. You see that? So if we were to say do show NTP associations, a little less output, right? Still showing that he's unsynchronized. So let's do this. Quick way to fix this would be to say no NTP server 172.16.99.111, and then just to pull this back, Control A. Bring the server back. Where's that server step? Got out of global config accidentally there. So NTP server 172.16.99.111. And let's see what we get over here. We should have some messages that get fired out from .4. There they go. You can see they're coming in. Messages are received. They're not being restricted and do not served. So do show NTP status. We are synchronized. Stratum 10. All right. Well, this was a great lab, a great opportunity to take a look at some debug output again to validate, is my access list doing what it's supposed to do? Or I should say, the access list in conjunction with that NTP access group. And we have to allow the peer, right, to the 127.127.1.1. And we also have to allow serve only because we're serving up NTP services off of that master server. All right. Well, this is a lab that we're going to be knocking out tomorrow night in class. Thank you guys for watching, and I will see you tomorrow evening. Enjoy the rest of your weekend.